Artificial. Have you ever had an amazing idea or seen an incredible achievement and in the end thought how fantastically disappointing that all was? Artificial intelligence has been described by many to be potentially the greatest cause of the coming about of the end of the world. And they're not fully wrong, as it would be the end of our species, very likely. Anyway, before we get started, there are a few requirements that are necessary. The first, you can't have much of anything that resembles a life. All those events, all those societal obligations, all of those relational obligations, those can go. And chances are, if you've considered going down this path, then you don't really have many of those to begin with. You will also need to create your own artificial intelligence because you've nothing better to do. Or, at least if you even do have something better to do, you're going to waste all your free time instead of making potentially healthy and wise decisions. So most of our coding is going to be done through traditional programming languages. I personally am going to use C# because C# is great. Also, I started programming with Unity and it comes with it. So. Now of course some of you are asking, why go out of your way? Why not just build this 100% in a typical programming language, make the whole thing a whole lot easier? And the thing is, you can't really do that. Programming languages are great, but they only go so far. Any variable written in a programming language like floatx equals 5.0 for example, those are temporary values. There's no way of storing older versions of that. Well, that's enough boring banter for a lifetime, so first things first, my tech sucks, I'm poor, it's a miracle I'm still alive up to this point. No, you can't take them, they're mine, you can't have them. We decide what is and is not yours. No, they're my memories. Ah! Doctor, what's the prognosis? I'm afraid he's brain dead. No! Lobotomy complete, check. I don't know if you were an organ donor. That was a touching experience. It really tugged at my heart tendrils. I never knew I had. The computer's dead, we lost a lot of work, but it's alright, we've got a backup strategy. Introducing the Toshiba Tecra! It's a dream machine! We're gonna need some tea. Look at this, you're gonna raise a glass and it's gonna be like, up yours, neighbor. Bloody good update. So I'm actually going to be driving to work today with squeaky brake shoes because I don't have enough time to do them today and I don't have my priorities straight. Let's get started! Okay, so this is a laptop, a computer. I'm sure you've seen one before. What I'm sure you haven't seen before is a display of such poor ownership as this. See, I've got the power ribbon that just tore apart. Dognammit, my computer won't start. Have you ever wanted to go far and be more like? Well, now it's easy. Simply reach into the computer and grab the power ribbon. Turning on a computer has never been easier. It's just common sense. Top 10 anime villains. So clearly not all my technology is outdated. Pay no mind to the carburetor on the floor. Well, hello everyone. I've not made a single ounce of progress on my project for, a couple months now. I've been caught up with anatomy and... What is the deal with anthropology? I have to write a 10 to 15 page paper by Monday, in a couple days from now, and I'd rather continue this project than start on that, so here goes. Where we left off, if we left off, I don't even know how much of the project I'm actually telling you people. But the point is, I was able to search variables up through abstract means. It made it an entirely unique programming language for that reason alone, that it was capable of, I suppose, implicit means of lookup. in a very strict sense that it was able to form abstraction. So now we've extended functionality to heuristics themselves, because we have a crap ton of heuristics that are able to do any sort of thing really to assign the same outcome. We have a new one for each and every context, and each and every context is extremely unique or slightly improved than the other. So now that we have the ability to look up heuristics, we're going to choose which ones are more likely to be valuable in given context, just using superficial measures to determine that. And once we find which ones to run, then I can make sure that my rules work once and for all. And wow, you all missed quite a lot, but the project's basically over. Sorry. Welcome to the dark world, thusly named for its immense darkness.
Okay, before you say anything, yes, this was written in Unity. I'm very basic. Visual Studio is extremely laggy and my tech sucks, so I'm as equally ashamed as you are. So let's get on with the actual code then. Right here I created my own namespace. I call it CSL Engine. It's Zeta because I have failed many times. I've needed to rewrite the code because this is a complicated project. Would you look at that? So you can just ignore this stuff right now. What's really important is this little section right here. So what makes CSL Engine an implicit programming language rather than an explicit one is it can use abstraction, and it does this through not directly mentioning variables but through mentioning search criteria for variables. So right here I've got a ton of variables. Fluffles is described as fluffy, Fluffles is described as cranky. So instead of describing it as a float or a string, some values can be both, right? Especially in games, if you have like an NPC or a humanoid, these are overlapping values. So I don't have booleans in CSL. What I do have is just an infinite supply of attributes and ways of describing variables. So we can also describe relationships. So instead of just saying Fluffles equals fluffy, we can say Fluffles' nemesis equals darkness. And over here we can say darkness is mystical or some crap. Sniffles' nemesis is darkness. Anyway, so right here we have search parameters. So we want to find a variable that's fluffy and who has the abstract relationship of something that is described as mystical. And we can insert commas and have more information to go on. We can insert another layer of brackets if we insert another relationship, and it can go on infinitely. So here we have a heuristic, and the return value of this heuristic is stupidity. Now, I haven't looked at this code in a while, I don't really know what it says. It takes an input value of something that is both fluffy and whose abstract nemesis is something described as mystical, and if it qualifies this heuristic, then this input variable will inherit the attribute of stupidity. Although for some reason I set this up as a relational heuristic so that there's a third value that this searches for here. That doesn't make sense. I was probably delirious while writing that, but anyway, let's just move on. So we should look for all things that are fluffy and whose nemesises are described as mystical. So let's give it a go. And I believe the debug.log statement was on line 49. So, hey, Fluffles and Sniffles. So those are both variables that satisfy the argument. Also, how CSL Engine runs is through all these tabs up here. I'm not going to click on them or show you them because that's kind of my life's work. Although I think strand abstraction is the most dense one. It probably has 1,000 to 2,000 lines of code. So, yeah, so why this works is Fluffles' nemesis is darkness, but so is Sniffles' nemesis. And darkness is described as mystical. So in both cases, they're going to qualify since they have the same relationship. So they both match the search criteria. Let's call it something else. So sniffles is blackness. Now if we run this, instead of returning fluffles and sniffles, it's going to return, oh, look at that, fluffles. Okay, I'm going to change this to darkness, and I'm going to change this to blackness, and now it should return sniffles instead. And oh, look at that, sniffles. Okay, so fantastic. That's actually pretty boring, but what it does is in this first, I suppose you can say this first layer of depth, we describe all attributes, but this is a relationship. It takes a third parameter. So here, we search up the relationship, and then we discriminate against the relationship further. So we can use this in languages to build syntactical meanings. So this is how I communicate to the program, and this is how I compute natural language processing. So what I have going on right now, the sentence here is, what is it? I like gloomy, rainy, I think it's joyless days. So that's the sentence. Now there's a lot more information going on up here. Why? Because English has a crap ton of words. It's got like thousands and thousands, and this program is still really new. It doesn't know all these words, so if it hears the word like, what does that mean? It doesn't know. It's a computer. It's had zero real-world experience. It doesn't know what like is. But in the same way that I'm able to attribute stupidity to either fluffles or sniffles depending on the search criteria and discriminant stimuli, then I can create assumptions. So I could very well find out that this is a verb. I could very well find out that it relates to the concept of liking something or enjoying something. I could find that, but there are way too many words in the English language, so right now I'm giving it a little bit of help. So instead of it having no idea, I'm just telling it for now that this is a noun and it refers to the concept of me. So the word I is a noun, it refers to me. Like, I'm telling it it's a verb and it refers to the concept of liking. You can also say, here, let's just, for sake of variety, put enjoy instead. A is an article. So it understands the rule of language, but because there are thousands and thousands of words, I'm telling it what these individual words are, even though it should be able to do that if it has experience with the word, as we see in that example. Okay, so gloomy has the concept of gloomy. I put a C here just so that you know it's not just a repeat of the word, it's actually the concept of gloominess. And then rainy, and I put a lot of adjectives just because I want to show you the infinite complexity that this program allows for. And then days is a noun and it refers to the concept of being a day. And so let's save that and run it. And we're going to get a lot more information this time. Ooh, meaning. Ooh, look at all this fun stuff. So right here, the sentence I just wrote is, I like a gloomy, rainy, joyless day. Okay. So it determines something is an article, even though we already knew that, so that's redundant. Here's something interesting. This is a relationship between two data points. This is the object of an adjective. And so it takes starting with 0, this would be the 6th item in the list, and it says the object of this adjective is the 7th item in the list. So I like, I'm not going to count, but you guys get the idea. It's looking at joyless and it's saying days. Now here, looks for the object of the adjective, starting with the 4th item in the list, going to the 7th one, and then going to the 5th item in the list and going to the 7th one. So we just did gloomy and rainy. So with the last one, we filled in joyless, filled in that relationship. In this one, we filled in gloomy and rainy. Okay. Objective of adjective. Okay, this is really redundant at this point. You can pause if you care, but adjective of object. So this is the fourth, the fifth, the sixth one, and oh wait. Oh yeah. So this starts with the object, which is the seventh item in the list each time, and then returns the fourth, the fifth, the sixth items in the list. Woot woot. So it performs the relationships both ways. And subject of verb. So starting with the second item, it refers to the first. So the verb is the second item, like, and it refers to the first, which is I. So the subject of the verb relationship. Okay, this is all redundant. It has different heuristics of finding the same answer. So noun, object, you guys get the point. So here it takes the very last item. This is the fun stuff. This is where we get into dense values and tertiary abstraction. So we take the seventh item in the list, and then it defines this as something that is described as the concept of day, described as the concept of joyless, described as the concept of rainy, described as the concept of gloomy. So what it did is it searched for all relevant data and compiled it. So it looked at all attributional data like adjectives and put it all together. It even took the implications of its noun. So here's the verb, and let me just fast forward because you'll see something a bit more impressive. So this refers to the first word, which is I in this case, which is the subject of the entire freaking sentence. So really this is the meaning of the sentence as a whole. And to show that it allows for infinite complexity in organizing the hierarchy, syntactical hierarchy of the sentence, let me show you. So the subject has this data point of meaning, and the value of its meaning is an anonymous value, which can be described as me. It also stores a relationship of enjoying something, and this relationship is related to another anonymous value, and this anonymous value is described as being like a day, as described as being joyless, rainy, and gloomy. So there you have it. It just read a sentence and made sense of it in the way that it was supposed to make sense of it. So obviously this program has limitations, and most of them have to do with its limited understanding of the English language at this point, and that's because there are thousands of words and it takes time to learn all that. However, I do want to get into riddles and metaphors, and it will have a really truly human understanding of this concept in a short time. I'm hoping by the end of this summer. And following analogies and metaphors will actually be a simple thing. I hope I've demonstrated well how this system works, and so you can easily see that any of these individual meanings it assigns these words can be substituted for the metaphorical value, and then it can work that into its understanding of the sentence. So it can have a figurative understanding of it as well. So right now this program has no sentience. We're only working on the cognitive side, and we're capable again of discriminating and finding only things that match all of our search criteria. We're also capable of random mutation of rules and natural selection of the beneficial ones, the ones that prove to be more accurate based on its reliable memory. We also have heuristics. We can assign the value of stupidity given that this other search criteria checks out. We have sentence rules that allow us to discern meaning. So I enjoy rainy, joyless, gloomy days. So in a bit here, I'm going to create a run-on sentence, and it's going to compile it beautifully in the correct way. Not now because I have work today, but in the near future.
It's dark and dank. Enough of it, I say. We must go outside. We must see the world. We must make our mothers proud. But before we do, I must siphon out some ATF or else my transmission may blow. Up yours, neighbor. I feel like this video is 1% AI, 99% problems I struggle with. Figuring out my life. Well, as usual, I could have just fixed a couple major problems, or my car may be done for. The children. Ugh. I should write my anthropology paper on anthropocentrism, but I would much rather go to a bar. Took an exam and my 10-page paper is due this evening, but oh no. Look, it's a beautiful day. Going on a bear hunt, we're gonna catch a big one. What a beautiful day! We're not scared, can't go over it, can't go under it. Oh no! So my milestone for the project is due in a week, but fear not. We've done most of it, and I have slacked. I've slacked considerably. However, the project has been mostly done for a while. We've been capable of running abstraction rather than looking up for variables in classes through explicitly, directly mentioning the variable's name. Then we can search them up through matching criteria and the attributes of relations and shared pathways and all that fun stuff. So we're also working on the natural language processing component of it, and we've gone considerably far with that. We're able to attributionally and relationally define data chunks and relate them and use rules that use this complicated web of information to construct a sentence in a purely syntactical sense. This most adequately describes a bottom-up processing approach, although the two are not as distinguishable as psychology classes seem to depict them as. However, that would probably be the best way of classifying it, since it has really no real-world experience at this point. No matter, we'll get there. So at this point, I think a number of you are wondering, what are my end goals? Well, once we're able to get a robot to understand language entirely, that means it can pass the Turing test, it can get riddles, it can think on the same level as a human, and language is so complex that being capable of doing so should it should in the same way qualify it to be able to do all the other stuff. Because in order to be capable of language, then you need rudimentary cognitive abilities, which we have demonstrated the AI currently has. So my end goal of this is actually quite funny. Ultimately, I want a way of being able to convert neural and digital data one from the other and potentially transfer them back and forth. And that is another ambitious project, so I'm not even going to begin to talk about it now. So what you can expect for the immediate future is I will get this video out. It will be capable of natural language processing. It will be a rudimentary AI. Well, not rudimentary, it will be more AI than any other AI I've currently seen. So I'm still a busy person. I have work, I have friends, I have somewhat of a social life. I try to maintain those things. And sometime this summer I'm going to update it. It's going to be able to handle language on a much more complicated scale. It's going to be capable of metaphors. And before you critics say anything, yes, I already have a system in place of doing that. In fact, I don't really need to add much. I already can use the old system. Metaphors are actually really simple to handle, and phrases and analogies in language, they should all be rather simple. I created an AI, a cognitive agent, an artificial agent, so I should be able to do that, and I already know how, so I'll get there. Later this summer, it's going to be capable of language and hopefully sensory input, so it'll be able to be a lot more. Anyway, eventually we'll get to the robotic side, and that'll be good and all. Yeah, you guys don't care.